In Step 6 of exercise number 3, the following actions have to be implemented to define the rough machining of the pocket ledges. Add a new iMachining operation. In the SolidCAM Manager, right-click Operations, Add Milling Operation, and select 2D iMachining. The iMachining operation dialog box is displayed, and the default iRough is used for technology. On the Geometry page, click the New button to define the machining geometry for the pocket ledges. For this operation, the geometry is defined as two separate pockets with open edges. For each of the semi-open pockets, you have to select a single closed chain on the pocket contours. In the SOLIDWORKS graphics area, pick on the lower contour of the first semi-open pocket as shown. Select Auto Constant Z in the Chain section of the Geometry Edit dialog box to close the chain. Click the Yes button to accept the selection. The chain icon is displayed in the Chain List section. Then, pick on the lower contour of the second semi-open pocket as shown. Select Auto Constant Z to close the chain, and then click Yes to confirm the chain selection. Chain 2 appears in the Chain List. In the Chain List, right-click Chain 1 and choose Mark Open Edges. The Mark Open Edges dialog box is displayed and enables you to define parts of the chain as open or closed. In the SOLIDWORKS graphics area, pick on the two outside edges as shown. The entities are now marked as open, and iMachining can use them for entry. Click OK to accept the selected edges as open. Right-click Chain 2 in the Chain List and choose Mark Open Edges. Pick on the two outside edges relative to Chain 2 as shown. Click OK to accept the selected edges as open. The geometry is defined. Click OK to confirm the geometry selection and exit the Geometry Edit dialog box. Switch to the Tool page of the iMachining Operation dialog box. Click the Select button to display the Part Tool table. Select the already created 12 mm diameter end mill with a cutting length of 24 mm. Then, click the Select button to choose the tool for the operation and exit the Part Tool table. Switch to the Levels page of the iMachining Operation dialog box to define the milling levels for the operation. Click the Upper Level button to define the upper machining level. Select the top face of the target model in the SOLIDWORKS graphics area as shown. Click OK to confirm the selection. Next, click the Pocket Depth button and select the lower face of a pocket ledge for the machining depth as shown. Click OK to confirm the selection and display the iMachining Operation dialog box. Switch to the Technology Wizard page to see how the cutting conditions were automatically calculated based on the tool information and milling levels defined for the operation. Looking at the output grid in the step-down section, you can see that the wizard calculated one step down at 14 mm because the total depth is still less than the cutting length of the tool. Note the ACP value is now set to 1.9 and the field is painted green. To show where the 1.9 ACP comes from, I am going to switch to a fully modeled end mill representing the current tool at a step down of 14 mm. By looking at a sectional view, you can see the number of contact points the tool has with the vertical wall it is producing. There is one contact point above the bottom of the end mill and 0.9 of the next. Moving back to the Technology Wizard page of the iMachining Operation dialog box, the green color in the output grid is an indication that the current situation for stability is good. Although the depth did not give us a perfect 2 ACPs, there is a 20% tolerance on any ACP over 1. In this case, 0.9 of the next ACP is within the 20% tolerance, and the depth gets painted green for good stability. It is not always possible to be machining with preferred ACPs, but by monitoring the ACP values and cutting results, over time you may find that matching a tool to the current depth to get good ACPs is beneficial. For this particular iMachining operation, reduce the machining level by 1. Decrease the machining level slider to 4. On the Technology page, the step down and cutting angles generated by the wizard are shown. By default, A 0.24mm allowance will be left on the walls. On the link page, the helical entry settings do not apply to this particular geometry. iMachining will enter and exit the cut where it calculates best. At this point, the operation can be calculated and the iMachining toolpath can be viewed on the model. Name the operation iRough Pocket Ledges. Click the Save and Calculate button to add the iRough operation to the cam tree and calculate the iMachining toolpath. Click the Simulate button to display the simulation control panel. Using the default HostCAD simulation mode, click the Play button to show the wireframe toolpath on the model. The tool approaches from outside and performs the roughing toolpath on the first semi-open pocket, and then rapids over and performs a similar toolpath on the second semi-open pocket. Using the exit buttons, close the simulation control panel and the iMachining operation dialog box. At this stage, Step 6 is complete and the wizard automatically calculated the ACP value based on a 14mm total depth. The exercise has come to an end. To close the cam part, right-click the cam part header in the SolidCAM Manager and choose Close from the menu. If you have not followed along, apply and practice the procedure shown in this video to define the rough machining of the pocket ledges and close the completed cam part.